Book 285, scientists trained honeybees to recognize human faces, showing how tiny brains can distinguish faces by the arrangement of their features. In a fascinating experiment, scientists trained honeybees to recognize human faces. The bees learned to pick out a specific face and keep recognizing it even when it appeared from a slightly different angle or among new faces. This was a remarkable discovery, not just because bees have no use for recognizing people, but because it showed how much brain power a task like this actually needs. The scientists used a technique called differential conditioning to train the bees. They showed the bees a target face and a similar distractor face and rewarded them with sugar when they chose the target face. The bees quickly learned to recognize the target face even when the distractor face was swapped in. They were also able to recognize the target face when it was rotated by 180 degrees, although their performance dropped slightly. Two of the bees were even retested 2 days after their original training, and their memory held up remarkably well. One bee scored 93.9% on the first day and still managed 79.2% 2 days later, while the other went from 87.4% down to 75.9% over the same gap. This showed that the bees had formed a long-term memory of the target face. But how did the bees manage to recognize the faces in the first place? The scientists discovered that the bees were using a technique called configural processing, which involves recognizing the arrangement of features on a face rather than just individual features. The bees were looking for a specific configuration of eyes, nose, and mouth, and were able to recognize faces even when the individual features were changed. This discovery has important implications for our understanding of brain power and facial recognition. It shows that even tiny brains like those of honeybees can learn to recognize faces, and that this ability is not limited to specialized brain regions. It also suggests that facial recognition might not need a purpose-built neural module, but can be achieved through general-purpose visual processing.